Hey, it's Lee Halliday, and today we are playing around with React and Web3, aka the blockchain, aka decentralized apps, aka DApps. And what we're going to be building is this sort of simple nav bar that, well, our React app is going to connect to the Ethereum network, and it's going to basically tell us which network are we connected to, a main net versus a test net, what block are we on right now, which account is connected, and how we're going to connect to this is through Metamask, which is it's a browser extension you can add to pretty much every browser out there that allows you to have a wallet in your browser, and it's really popular for these DApps. So once we've connected our account, it can now tell us what our account balance is, and we're going to give the option to sign a message. And signing a message is what you could use to basically do login or authentication through this MetaMask Ethereum account. So this is what we're going to be building. This is all faked out right now. So our job over the next, I don't know, maybe 20 minutes or so will be to bring this thing to life. So quick overview of the code we're working with. We're basically bringing in two different packages. We've got this Web3 React, which brings in core and injected connector. This is just some React niceness. It provides a provider so that you can access sort of whatever account you're connected with anywhere in your application. And it works with a number of different wallets you can connect it to. We're also working with Ethers, which is a really popular JavaScript package for connecting to the Ethereum blockchain. So we're going to be digging into this in a sec, but what we've got in our React code is right now our home sort of exported default React component is just rendering app. App has some fake data. Basically, is it active true? What account? Is it just hard-coded? So if we change this over to false, this is what we're going to be starting with, and connect is the button we'll be clicking. And I've got a hard-coded Ethereum balance and a block number. So we're going to be bringing this all to life. And below we've got some code that basically just says, is it active, meaning connected to your MetaMask wallet? If so, show what network, what block, the account, the balance, and give the ability to sign a message. Otherwise, show a button that says connect, and when we do this, we'll want to basically try to connect to MetaMask and activate this sort of website with our MetaMask wallet. So that's what we're going to be building today. So let's get started, and the way we get started is right up here in this exported default home component. So why would I have separated these function app from this exported one? Basically because I want to wrap a provider around this. So the provider we're going to be wrapping around this is Web3 React Provider from Web3 React Core. So we'll just wrap that around, put our app in the middle. And I should give this extremely large caveat that I am by no means a Web3 blockchain DApp expert. I've been figuring this out myself over the last few days, and I'm just sharing what I've learned. So don't take this as expert knowledge, just somebody figuring it out like everyone else. So this provider, what it needs is a library, a get library, and that prop is a function which is going to receive a provider. So we'll just say it's any, and then what it wants to do is basically return the provider. So the provider we're going to be providing is this Web3 provider from Ethers. Why would you have to do this? Well, this Web3 React package works with not just Ethers, but another way to connect to Ethereum as well. So this is basically how you tell it to connect to one versus the other. We're working with Ethers. So what we're going to be doing is returning a new instance of Web3 provider. And what we need to pass to this is just the provider. Cool. So still, it does absolutely nothing yet. But what we can do is instead of just hard coding this, we can basically replace it with a hook called use Web3 React. Just like that. So right now, active should be false and there shouldn't be an account. It should look the same. But what this allows us to do is to add on another value that we get back from this hook called activate. And activate is a function we can call to basically connect this web browser to our Metamask wallet. It can actually connect to a number of different wallets, not just Metamask or Metamask. Look into the docs to figure out how you connect the different wallets out there. Let's now take this activate function. So if it's not active, it shows this button here, and on click we want to activate the wallet. So what we do is we call activate and we need to pass in a connector. So a connector is which wallet are you going to be connecting to. So remember I told you we're going to be using Metamask, and the way Metamask works, it basically injects something into the page of your browser. So the way we're going to be working with it is this injected connector from Web3 React. And we're going to be passing in a new instance of that. I think I messed something up. Why is it not? Oh, I know why. Like that. So before I even click this button, I want to show you that if I type window.ethereum, it's actually something. It exists. It's been injected into this page. So this MetaMask that I'm running as an extension has injected a window level object called Ethereum, and this is how I interact with my MetaMask wallet. Now I can interact with it directly. It's got a whole bunch of different functions we can call on it. Is MetaMask, enable, send async, etc. We aren't going to be doing that though, because we're using this Web3 React, which does a lot of that heavy lifting for us. So with this in place, if I were to click this button, connect, it pops up Metamask and it basically asks like, hey, which of your Ethereum accounts in your Metamask wallet do you want to connect with? So I'm working with this test one here. So we'll say next. Now it asks me like, what permissions do you want to give? There's only one right now and you have to give it to view the public address of your permitted accounts. So we'll say connect. So it says connecting here, it disappears, and now we're active or we're connected. And remember, this is still all fake information, except this actually. This account comes from Metamask now. So that is my actual public Ethereum account address. So I'm just sort of stripping out some of this, but if I were instead, I could just show the whole account. So this is my public account. I'm just sort of getting the first date and the last date to shorten it a little bit. So I'm going to get rid of that again. Cool. So now over the next little bit, we're going to be trying to bring these to life. Let's get actual values. Because if you see, I actually have 5 Ethereum in my account. This is not an actual Ethereum account. I am connected to a test network. So Ethereum has a number of different, think about when you're doing development, you have like staging, production. This is sort of Ethereum's version of that. You've got the Ethereum mainnet, which is the real network, the real money. Now we've got the Ropsten test network. That's the one we're using. I've got 5 Ethereum in this test network. So we need to fix that to make it work. We also want it to say test network, and we also want it to show the actual block number that Ethereum's at. So the first one's pretty easy. What we can do is we can get the chain ID. So chain ID is just a number that represents which of the Ethereum networks you're connected to. So 3 is that Ropsten one. 1 is the mainnet. So what we could do is we could just say, if it's 1, we'll say mainnet. Otherwise, we'll say testnet. And you could go down into the level of detail of like 3 is Ropsten versus some other network. We're not going to. We know we're connected to a test network right now, so that is working correctly. So why don't we next go and get the actual balance from my wallet. So for that, I'm going to replace this hard-coded value with a hook called useBalance that doesn't exist, but we're going to go create it. So function useBalance, and it's going to be returning whatever 5 ETH. So if I were to, there we go, it's displaying, but we actually want to get the real balance, right? So what we're going to do is we're going to first grab the account and something which we haven't worked with yet called the library from use Web3 React. And we're going to set up some state to store the balance. So balance and set balance, and that will be use state. And what we want to do is basically return the balance. But we need to get the balance from somewhere. So for that, we're going to use effect. And we're going to do an effect on the account and the library. And because this hook runs when we might not be connected or active, what I can do is just put an if statement. So if there's an account, that means we're active. And so now what I want to do is basically work with the library. And the library, I can ask it to get me the balance of this wallet for a specific account. And it gives me a promise. So I could do async await, or I can do then, which gives me the value, and I can set the balance to this value. And big fat error. So why are we getting an error here? Because what it's actually returning us back isn't a nice displayable number we can work with. It's something called a big number. And this, we need to format in some way. And so from this Ethers project, there's this units package that gives us a function called format ether. So what we can do down here is we can say, like, if there's a balance, we want to format this ether. We'll pass in the balance, otherwise we're null. So let me just reconnect. So here's 5.5, that's what I have in my actual wallet. If I want to make it a little bit nicer, we can say ETH, just like that. Cool. So now it's showing me my account number, the network we're connected to, and how many Ethereum are in my wallet. Next, we're going to work on this. Let's get the actual block number. So Ethereum, every however many seconds, produces a new block number. It's writing to the blockchain. If we, for whatever fun, we want to show, here's the block number we're currently at, and it sort of update every time it changes, we can go and use the library to get this value. So remember again, what is the library? The library is what was passed into the provider, which in our case is the Ethers provider. So it's this Web3 provider from Ethers. Okay, so we're going to do the same sort of thing, use block number. And this will be a little custom hook we create. Oops. Function use block number. And we want to first get the library, so that would be Ethers from use Web React 3. And we want in state to store the block number, so set block number. And that would be just use state. And then what we want to do is basically just return this block number. Cool. So it's nothing yet. It isn't failing though. That's great. But to actually get this block number, we're going to use an effect. So use effect hook. And we're going to run the effect on the library being there. So we'll just put a check in here to say, like, if library, we want to do something. So what do we want to do? We want to basically tell us library on whenever there's a new block, it receives a function here that has a val, and this val can set block number just like that. So if I were to come back, this is the current block in the Ropstein test network, and if I wait enough time, it will receive a new event and it will count this up to 700. So while it's sort of waiting for the period of time before it goes to the next block, why don't I come back and just refactor this code a little bit? And the reason I want to refactor it is if for whatever reason we unmount this app component, we basically want it to stop trying to update the state here, because it's gonna cause an issue, and we basically want it to say, hey, stop listening for updates when this unmounts. So to do that, what we're going to do is basically create a function here, and we'll call it update block number. And it's going to just be the exact same code we wrote below. So now we'll just pass in this instead. And the way that useEffect works is we can return a cleanup function that will be called. It will be called anytime this changes, but this will change when we unmount. And so what we can do in here is we can say library, and we want to say remove event listener on block. This is the event listener we want to remove. So just save that. So you can see here in that time I was coding, it's actually counted up 5 blocks. But the refactoring we did is basically move this function that sets the state into its own variable. And then we can pass that variable in here and then return a cleanup function that will remove the event listener on block for that event listener function. Cool, and it counted up another couple blocks while I was rambling on. Okay, so the last thing we want to do is basically this sign in. So this is all about signing a message, and we'll talk about what that is in a second. And we'll talk about it while we're doing the code. So sign in. So signing a message is basically using the cryptographic power of the blockchain of the Ethereum network, and that inside of my Metamask wallet is the private key. And the private key allows us to basically sign things, sign pieces of text. It also allows us to send transactions, to send money from one account to another. We are not going to be doing that. We're just going to be signing a message, which basically just takes your private key and signs whatever text you pass into it, gives you a signature, and you can use that sort of to verify that the account that claims to have signed a message is who they say they are. So once we get the signature back, if we were going to build out a backend, we could send all of this data to the backend. It could verify that the person is who they say they are, and then it could return like a JWT token or something like that and log the user into your website. So you could basically use Ethereum and Metamask as an alternative to like email password, to Google Connect, stuff like that, all by signing a message and verifying that it was signed by the correct account. So the way we're going to be doing that is we'll start by just setting a message. And the message we'll set will just say something like logging in at, and then a time. So new date dot to ISO string, like this. Okay, so once we have the message, we need to now sign that message. So we'll start by getting the signature, and this is going to be an async await, returns a promise. So we need to wait the result. And the reason I can do that is because I added async up here on this on click for the button. So we are going to be using the library again, and we're going to be asking the library to get the signer for an account. And if you're wondering where all this comes again, actually library wouldn't work yet. So we've got library, which is ethers. We've got account, and that's the Ethereum account that we're connected to in the wallet. And what we can do then is, after we do that, we'll sign a message. So which message are we going to sign? This piece of text right here. And just save that. So because this is a promise, it may fail. So we're going to catch, and if there's an error, we're just going to console.error log this error. And so you may want to show on the screen somewhere like, hey, there was an error. I'll show you what sort of errors you might get back. But at this point, we have the message, we have the signature of it, and then we have the account. Those are the three important pieces if you were to send this to a backend and verify it against the network that, hey, the account that claims to have signed this message matches up. So we're just going to, for now, the sake of this, we're going to log out the message, the account, and the signature. That's it. So we're not going to do the full login thing in this video, maybe in the future, but let's see how it works. So I'm just going to refresh here, connect, click sign in. So when you go to sign a message, it pops up Metamask again, and it says like, hey, there's a signature request. Here is the message logging in at, and then that timestamp. So I can click sign. If I do click cancel, that is when it throws an error. So remember, we logged that error out here. So it just says user denied message signature. So we'll just click it again. It pops open Metamask again, and this time we'll sign it. So once it's been signed, we just logged out what account signed it or claims to have signed it, what was the message that was signed, and then here is the signature. So you pass those to a backend. There's a function in Ethers, verify message. So you basically pass in the message that you just signed, the signature. So oops, it was in this one. So the message, the signature. What it then gives you back is the address that signed that message. And then you can compare the address that this function gives you back with the one the user claims to be. And if there's a match, you can assume that person owns the wallet. Otherwise, you wouldn't have all of this match up. And then you can log them in by creating a JWT, return that, and log them in here. So that's a bit beyond what we're going to be doing in this video, but at least gives you like an intro of how that works. And it costs nothing to sign a message. To actually like transfer a token from one account to another, that you would have to pay gas for, and Ethereum gas is really expensive. But you can sign messages and verify messages absolutely for free. So it's a great way to add authentication through the blockchain and your MetaMask wallet to an app. So that's all I really wanted to show today. It's a way to basically just connect React to the blockchain through the MetaMask wallet and get us some cool information, I think, that we could then use to build additional functionality. What network are you counted to? What block is it currently? What's your address? How many Ethereum do you have in that address, and the ability to sign messages. Hope you enjoyed the video. This is me learning about this stuff. It's brand new. It's not really stuff I have experience with, but it was fun to play around with, fun to learn. Hope you enjoyed it as well. Take care. Bye.